Alright, so today is day 2 of polynomials, and we are going to be looking at their degrees and how their arms go, so the end behavior, and what the multiplicity is like, and what their graphs would look like. So the degree of the polynomial and the leading coefficient tell you what the function's end behavior looks like, so it tells you how the arms go. If we think about n is your degree, so your exponent, and an is your coefficient to that exponent, and you're looking at the leading coefficient, so you're looking at the one with the highest degree. If we think about one that's even and positive, you can always think of x squared. Remember what x squared looks like? Both of your arms are positive. Now, what happens in between just changes depending on what our function is and how many zeros and such there are. So that's if x squared, or if it's even and positive, then both arms are up. So if we just made that negative, then both arms go down. And again, what happens in between just depends on what the equation is. If your exponent is odd and positive, so you remember what x cubed look like, then left arm is down, right arm is up. And again, whatever happens in between can be anything. So if I just put a negative, then that's going to flip this over, and again, what happens in between can be anything. So if I gave an example like that, and I wanted you to tell me how the end behavior is, so I'm just making this up, 4x cubed minus 6x to the 5th plus 2x minus 4. Okay, it's made up. It's not in standard form right now, but if I put it in standard form, this would be my leading coefficient. It has the highest degree. So this is what I'm looking at to determine what the end behavior is. So it is an odd degree, and it is negative. So because it's odd and negative, then the left arm is up and the right arm is down. This is the type of answer I want when you give me your answer on your homework. So the first 7 on your homework are going to be like that. Alright, moving on. Multiplicity is when a zero is used or occurs multiple times, and that multiplicity is equal to the number of times that occurs. So basically we're looking at the degree, and if the degree happens a certain amount of times, this is what happens. If your degree is 1, then it just crosses through at that 0. So let's say I had a 0 at that point, it would just cross through. If your degree is even, then it touches at that 0. So if you think about x squared, it just touches, it goes to that point, bounces off. If your degree is odd, if you think about x cubed, it's going to flatten through that point. So if I have some 0 here, it's going to get flatter around that 0. So it doesn't go straight across through, it kind of flattens towards it. So we're going to be using these 3 things and then how the arms look in order to find the zeros, multiplicity, and then sketch that graph. Alright. On here, it's already in factored form, so finding the zeros is fairly simple. You just take each one, set them equal to 0. So this would give me -2, this would give me +3. Now, the multiplicity is going to be how many times those 0 occurs, and you're going to be looking at the degree. So if I look at the degree on both of them, they're both 1, because that's their exponent. So your multiplicity is 1. Now, if your exponent's 1, it crosses through at those zeros. Alright, so that gives us how it crosses, or how it goes through the 0. Now we need to determine how the end behavior looks, so how the degree is. Well, in order to figure it out, it's in standard form. We have it in factored form. If it's in factored form, we can add the exponents, and that'll tell us our degree. So 1 plus 1 is 2. So that is even. And then it's positive because the beginning is, there's no negative. So if it's even and positive, both arms are up. So what we're going to do is we're going to take our graph, plot our 2 zeros. So our zeros are at -2 and 3. both arms are up. Okay, and it tells me that it crosses through both of them. So if it crosses through both of them like that, then I don't care how it's connected in the middle. I just care that both arms are up and that it's crossing through them. So that would be your sketch of this graph. Alright, so if we look at example 2, again, the 0 for this would be -2 because I had set it equal to 0 and solve. This one I'm ignoring the squared for right now, and the 0 for that would just be 1. Okay, the exponent on this one is 1. The exponent on this is 2. So if the exponent's 1, it crosses. The exponent's even, it touches. Alright, so now, because it's in factored form, I'm going to add my exponent. So my exponent is 3, so that's odd. And because of this negative side out front, it's negative. So that means left arm up, right arm down. So if we graph this, I'm going to plot the zeros. So I have one at 1, and the other is at -2. Alright, so left arm is up, right arm is down. Okay, at -2, it crosses. At 1, it touches. So it's going to go to that and bounce off. Okay, well now I need to connect those lines. So there we have it. Alright, I'm going to skip example 3 and move on straight to example 4. So I'm going to have x equals 0, x equals -3, and x equals 5. Our multiplicity is 1, so it crosses. Our multiplicity is 2, so it touches. And our multiplicity is 3, so it flattens. And again, I'm getting the multiplicity from what the exponents are on each 0. Alright, to determine how the graph is going to look, I'm going to, since it's already in factor form, I'm going to add the exponent. So 1 plus 2 plus 3 is 6. So it's even, and because the negative out front, it's negative. So even, negative, both arms down. So if we graph all of the zeros, I have 1 at 0, 1 at -3, and 1 at 5. Both arms down. Alright, if I look at the 0 that's at -3, that's here, it touches. So it's going to bounce off there. If I look at the 1 at 0, it's going to cross through. And then the 1 at 5 flattens. So I need to take this and somehow make it flat. So get flat around there. So I had to do a little fix in that so it doesn't go straight through. Alright, and again, what happens in between the zeros right now is not the most important part. Okay, so there is that. Now, example 5 doesn't look like the ones we've done before because it's not factored yet. So in order to factor, first off, from the way it is right now, it's in standard form, so I can go ahead and tell you how the arms are. Its highest degree is 4, so that's even, and it's a negative. So both arms down. Now if I factor out what they have in common, they have a -2x squared in common. So anytime there's a negative in that first term, you want to factor it out. So when we do that, I'm left with just x squared minus 1. So then if I factor x squared minus 1, I'm left with x plus 1 and x minus 1. Okay, here set that equal to 0. I just get x equals 0 and the multiplicity is 2, so it touches. Set that equal to 0, I have x equals -1. Set this equal to 0, I get x equals 1. The multiplicity are both 1 on both of them, so they cross. If we plot, I have 0, -1, and 1. Both arms down. It crosses through both of these, and then it touches at 0. So in order for that to work, touches 0, goes through. Alright, so last part on this note, write a polynomial function in standard form with the given zeros. So we're going to go backwards from what we've done with my father drives red Mustang. So I'm going to leave them as fractions, or put them as fractions if they aren't. Put an x on the bottom. And I need to flip the signs. So if it's negative to begin with, make it positive. And read going up. So I have 3x minus 1, x minus 2, and then that just becomes x. Okay, the reason you have to flip your sign is because these are the zeros. So if I were to set that equal to 0, I'd have to add 1, divide by 3, and I'd get my 1/3. Set this x minus 2 equal to 0, I'd have to add 2 and get positive 2. Set that equal to 0, and you just get 0. So that's why you need to flip your signs. Once you do that, it wants it in standard form, so you would need to go ahead and FOIL it out and factor from there. So if I FOIL this, I have 3x squared minus 6x minus 1x plus 2. So that's 3x squared minus 7x plus 2. And all of that is times x from here. So my final answer on this one would be 3x cubed minus 7x squared plus 2x. That's your standard form. Alright, the last one is, I'm just going to go ahead and put it in factored form, and I'm not going to show all the work on how to FOIL it out. You have x plus 9 times x minus 2, 3x plus 2. So I just put those in fractions, put x in the bottom, change the sign, and write up. Now, if you want to FOIL it out and you want to get an answer, this is the answer you should get. And you can do that and check your work. The assignment for this is page 318, that's a 3, 1 through 7, and then page 323, 22 through 28 evens, and 29 through 32 all. So the last part, 29 through 32, is like examples 1 through 5. So you need to find multiplicity zeros and sketch a graph. So make sure you sketch a graph on those. Alright, please let me know if you have any questions, and good luck.